let's get started on lesson 7, talking about parent graphs and transformations. This next page here, I'm just going to quickly show you this. These are some of the most important graphs. If you're going to have some memorized that you can picture, here's 9 of them that you should have in your brain. Okay. For example, right, the first one here is just a straight line. We kind of know that one already. That's whenever you just have an x. Okay. 1 over x will give you this shape here. Absolute value of x gives you the V shape. X squared, or actually any even powered, so x to the 4th power, the 5th power, will give you some shape that looks kind of like that one. Square root or 4th root or 6th root, again, even powers, will give you something that looks like this. An exponential will give you a graph that looks like that. Okay, and so on. This one here, if it's an odd power on the x, it's going to look a lot like the even powered one, except imagine instead of this part on the left side going up, it's now just been flipped over, it's going downward. Okay, that's essentially what's happening there. Cube root, same thing as the square root, just adding an extra wrinkle to it. And then the logarithm. Okay, so these are some of the most important graphs. If you have these in your mind, you can picture pretty much any function you're going to encounter. Okay. Okay. All right. So let's talk about the different types of transformations that can take place. So if you're given a function, imagine, depending on what you're looking for, you can move the graphs around. Okay. Or one graph is just another graph that's been moved over. Okay, so a translation is the first type of transformation. It's called a shift, also called a shift. And one thing you can do with that is, let's first identify some points here. Let's say that that's right. I know it's not exactly on the line, but we'll pretend like it is. Goes there, and this one here. Okay, so here's 3 points. If I wanted to shift this horizontally, I could move it to the right, let's say 2 spaces. So if I wanted to, I could say move this point 2 spaces to the right, move this point 2 spaces to the right, and move this point 2 spaces to the right. And then I can actually draw a rough sketch. I'm doing this by hand, but I'm drawing a rough sketch of the graph. And you can see it's the same graph, except moved over to the right. Okay. You could also have moved it, to the right and down. So let's say I want to go to the right 2 spaces and down 3 spaces. So right 1, 2, 1, 2, 1, 2. Okay, and then down 3 spaces from there. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so where these red points are will be the graph. Okay, so I moved it to the right and down. Okay, so that's called a translation, when you're shifting it over to the right or to the left, up or down. Okay, and so the 2 types of shifts we just talked about, there's the vertical shift, and you accomplish the vertical shift by taking the function and adding something to it or subtracting from it, right? So for example, if you had y equals x squared, okay, which the graph looks like this, and you wanted to move it downward, you could just say y equals x squared minus 4, right? Minus something. That would take the same graph, except move it down 1, 2, 3, 4 spaces. Okay, so a vertical shift, if you want to move something up or down, you just tack on some numbers to the end, add or subtract. Horizontal shift, you're going to change what happens inside of the function with x. Okay, so what does that mean? Start off with y equals x squared again. And let's say you wanted to add something inside with x. Well, that just means x, let's say plus 4. Notice where I put it, right? Notice the difference. In the last example, I said this, where the x squared is its own unit, plus 4. For a horizontal shift, the x plus 4 takes place inside of wherever X was located. So take X away and you put parentheses X plus 4. And this is going to be a shift to the left 4 units. So 1, 2, 3, 4. Okay, so something to keep in mind. And I'll kind of go back a little bit. Let's talk about this one first. If you add a number here, you're going to move the graph to the left. If you subtract a number here, you're going to move the graph to the right. Okay, so you want to keep that in mind. For vertical, I just want to write it out. If you add something, you move it up. Subtract something, you move it down. Okay, so up and down, left and right. Okay. So let's predict what the graph of this is going to look like. Okay, I want to describe what the graph looks like here. And so you kind of have to be careful, I guess, in the way you explain this one, because I'm not telling you what the original function graph looks like. It could be an x squared, it could be a square root of x, right? I'm not giving you that. But just based on the fact that something is happening to the original function, you can predict what that graph is going to look like based, off of the original graph. So to describe the graph of this one here, I would say that it has the same graph as f of x, or y equals f of x, but shifted or translated. And you add inside with x, that's to the left. Shifted left, 43 units. Okay, so whatever the graph looks like, right? Whatever it looks like. Let's say that was the original graph. Well, then this one's going to be shifted to the left. Okay, well, I can't tally up 43 spaces there, but that's kind of the idea. Okay, so then this one here, x minus 4. Okay, well, that's the same graph as y equals f of x, whatever that happens to look like, but shifted. Okay, that minus 4 is happening inside with x, right? It's not on the outside. It's not on the outside. It's inside with x. And it's subtraction, so that means I'm moving it to the right. So shifted right 4 units. Okay, compare that one to the one at the bottom there. Okay, notice I'm adding 5 on the outside here. Outside means that's a vertical shift, and we're moving that one upward. So this one's going to have the same graph as y equals f of x, but shifted up 5 units. Okay, so those will be the translations. Okay, so let's use this function right here. Look, I used t instead of x. Okay. Doesn't have to be x, right? I want to see if I can maybe graph this one. Okay, and just to be nice, here is the graph of y equals x squared, which is what this is based off of, right? If you look at wherever well, it's t in this case, but where their variable is located, it is inside the parentheses where it's being squared, okay? So you find this, you kind of ignore all the numbers around it. You find that and look at the exponent, it's t squared. So y equals x squared is my parent function, my parent graph. And it looks like this. Now I want to identify what are the transformations that are taking place. I see +1 inside of the parentheses. Okay, so that means I'm going to the left 1 unit. I see -3 on the outside. So I'm going to go down 3 units. So my new points will be left, try that again, left 1, down 3. And so good idea is to find some points that's on the original graph so you can track those. So there's a point, there's a point, there's a point. I'm just looking at the graph, seeing where they actually cross intersection, some lines neatly. All right, so each one, let's track them. So left one, down three. So starting at the origin, left one, down three. Okay, this point right here is going to now be left one, down three, left one, down three. Taking this one now, left one, down three, left one, down three. This one is now left one, down three. Oops. And left one, down three. Okay, so here we go. So there's the sketch of the graph after the transformation. Reflections, that's the next type of transformation that we'll talk about. Okay, so those are the two most common, by the way, that you'll see. Well, maybe not the most common, but anyway, here's reflection. So reflection refers to either a vertical reflection or a horizontal reflection. So a vertical reflection would mean take all the points and flip them across the axis. So if this is up 4 units, I will put it down 1, 2, 3, 4 units. This one was down 2, now this one is up 2. Okay, so my new graph will look like that, right? I just flipped it over. Every point has flipped over. That's a vertical reflection. A horizontal reflection would be going across the y-axis. So this one is to the left 2. I'll go to the right 2 now. This one is to the right 1. Go to the left 1 now. Okay, graphs look similar, but they are different. Okay, so reflections. The two types. There's a vertical reflection where you multiply the original function by -1, right? You just take the negative of the original function. So again, if you had y equals x squared, rough sketch there, this, the upside down version, would be y equals -x squared. Just throw a negative in the front. If you have an x or a negative inside of the function, x squared is a bad example here, but we'll use it anyway. If you change the inside, right? So in the last example, you put the negative on the outside. This one, you put the negative on the inside. If you do it that way, you get it reflected across the y-axis or horizontally. Now, you can't really see it, but what's happening here is the points that were over here got flipped to this side. Okay, now, why don't you notice? Why don't you see that? Well, what happens whenever you square a negative? It becomes positive, right? So you end up actually getting the same exact graph. That's why I said x squared was a bad example. But we can do something that's not as bad. Let's say drawing a blank. Let's say y equals the cube root of x. There we go. Well, if you change that to a negative, the part that was over here is now going to be on the opposite side. And the part that was over here is going to be on the right side. So there you go, you get this graph instead. That would be y equals that. Okay, so let's describe these graphs really quick. Okay, so this is going to be the same graph as y equals f of x, but shifted left 43 and reflected across the x-axis, right? So in other words, I don't know why I put that there. There you go. In other words, if it were shaped like this, now it's been reflected across the x-axis, so it's down here. Okay, so two things, plus 43 and the minus, or the negative in the front. Okay, let's try this one. This one's going to be the same graph as y equals f of x, but shifted right 4 units and reflected across it's on the outside of the function, so x-axis again. Okay, on the bottom here, well, this one, same graph as y equals f of x, but this one is reflected across the y-axis, right? Notice the negative's inside the y-axis and shifted up 5 units. Okay. Now, we're not talking about the last type of transformation, just because we don't have the time to do it right now. That's something we get to later. But there's another set, right, which would be scaling or stretching, or compressing and shrinking or something like that. Anyway, and before I do this example here, that would be whenever you multiply a function by, let's say, 2. Well, if you had something like this, now you've essentially doubled the height at each point. So whenever it was here, it's now going to be here. Here, it's now going to be there, and it's just going to be a steeper version. Or you could multiply it by, let's say, a half, in which case you would have a flatter version. Okay, and so there is vertical and horizontal components. We'll get to that at another time. Okay, we don't have time to do that today. All right, so let's write a function now. We're going to call that function h of x. That has the same graph as this here, 1 over x, but has been shifted up 4 units and reflected across the x-axis. Okay, and let's do it in that order. So my new function, if I wanted to shift it up 4 units, I would add 4 to the outside, right? That is a vertical translation, so I'm going to add to the outside. All right, and then I want to reflect it across the x-axis. That means flip it upside down. So I'm going to, let me do this in different colors so we can actually see it. So we'll do this one in red. And then in blue, we'll reflect it across the x-axis. That means put a negative in front of that whole problem. So we have h of x equals negative 1/2 x minus 4. Okay, I do want to reverse the order here. Okay, so this was the answer to this question. Let's reverse the order to see if it matters, the order here. Let's reflect it across the x-axis first, and then shift it up 4 units. Okay, in this case, you don't distribute the negative. Let's put that in green. So it makes a difference, right? The order that you do this in makes a difference. So make sure you pay attention to the order that it's listed. All right, let's see. I got a couple more examples here. Yeah, all right. So here's a graph. Let's just perform the transformation. These last two or so are just basically real quick. So first, identify the transformation here. I see a negative in the front. That's a reflection across the x-axis. Okay, so all these points. This is 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay. Do have 3, 9 here, although we probably don't need to track those. Okay, and if you are reflecting it, notice what's happening here. You are multiplying a negative times the function, right? Remember, that's a y value essentially. The function gives you y value. So if you're multiplying the outputs by a negative, you're just making all the y values negative. So if I were to make this y value negative, well, 0, negative 0 is just going to be 0. So we're going to be here. If I made the y value negative, I'd have a negative 1 here. So this should be 1, negative 1. This y value is a positive 1. So if I turn it to a negative 1, that gives me the point negative 1, negative 1. Change that y value to negative. That'd be a negative 4. So 2. And so on. So if I just go down the line, I can make all my y values negative. That was terrible. Okay, and so we just flip the graph over. It changes all the y values to negative. Let's compare it to this one here. This is one that we did not, well, I kind of mentioned it a little bit, but let's talk about now these points. So again, let's go back to the 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay, these points. Now notice, we just talked about this is a y value, right? It's a y value output. You're multiplying those y value outputs by a half. So if I do that with these points here, I will get 0, 0, because half of 0 is 0. This would become 1, 1 half. Okay, well, that'd be about right there. This one becomes negative 1, 1 half. Wait, that was not a good spot right there. Sorry. There we go. I was still reflecting it. Okay. 2, 4. If I cut that 4 in half, that'd be 2, 2. 2, 4, negative 2, 4. Cut the 4 in half would be another 2. Okay, and notice what it does to this graph. It kind of made it a little bit wider than it was before, right? A little bit wider. Okay, and so this is that other transformation that we didn't really talk about. Again, we'll do some more of this later on in the program, but if you see this, remember, it's just affecting the y values. So just change the y values by that factor. Okay, and I think that's it. Yep. All right, so stopping the recording.